I'm Anil Kumar, and we have a question on absolute function. We need to find absolute maximum or minimum for this particular function. So the question here is determine the absolute extreme values of f of x equals to absolute x minus 2, where x is greater than equal to minus 4 and less than equals to plus 4. I'd like you to pause the video, answer the question, take it like a test question, right? So we need to do 3 steps to begin with. Let's be very clear about these 3 steps. The first step is check continuity, right? So first step is check continuity, right? Second is to find critical numbers, and then to find the value on the extreme points given to you, right? I'm writing in general F, A, B, and C, where C is the critical numbers. Okay, so these are the 3 steps to be followed, and always you have to do these 3 steps when we're talking about absolute maximum or minimum, right? So the first step, check the continuity. So we know this absolute function is always continuous. It may have a corner at a point, but it is always continuous. So x minus 2 will be a function kind of like this, right? So I'm just sketching like this. Okay, we'll find the values later, write it down. Remember, it is not differentiable at 2, right? So it is continuous, which is not differentiable at x equals to 2, and that is why I've taken this example. So in some books they say to find absolute maximum minimum the function should be differentiable in the given domain. Well, that is not quite right. So here you can see this is actually the absolute minimum value, right? Okay, let's move forward. So we have this function, and let's find derivative of this function. So we have f of x equals to absolute x minus 2. To find the derivative of the function, it is good practice to write it as a piecewise function. So it is x minus 2, you can see, when x is greater than equal to 2, and when x is greater than equals to 2, and it is equals to minus of x minus 2 when x is less than equal to 2, right? So that is how the function is defined, correct? Now let us see. Okay, let's find the derivative of this function. This is the function, okay? We didn't find the derivative. So the derivative for this function will be, so when you do x greater than 2, the derivative will be 1, and when you do less than 2, it is minus 1. So this is the derivative. Now in our case, we are considering from minus 4 to this. So we will consider, we'll take this x greater than 2 in this, right? So we'll say between 2 to 4 in our case, right? So between 2 to 4, and this limit will be when less than 2. So we'll take less than equal to in one side. Okay, you could. So we'll take it. We'll define this one side. We have to take minus, right? So less than, and at this point, it's kind of, you could do like this also, right? Okay. Now at this point, or include it in any, let me include here. So for minus, we say, well, it is not including this side, so we'll say 2 and minus 4. I should write minus 4 and 2, sorry. So minus 4 to 2. So minus 4 to 2, we know it's a negative slope of negative 1. You can see, and you can understand what I'm trying to say, right? So, well, if I write my equation as I have written, in that case, f dash of x will be, I'll fill up here and then say this is kind of like this. And on the other hand, I'll make a hole here and say like this, right? I'm not writing the scale at present. So that is a derivative. So clearly it is not defined at 2, right? So what do we get from here? Since it is not defined at 2, that is our critical number, correct? So that is the whole idea. So what is the critical number here? So critical number here is the point where the derivative is not defined or it is 0. So critical number is basically where f dash x equals to 0 or where f dash x does not exist. So we have a critical number at 2. So x equals to 2, 2 is critical number, right? So that is what I want you to understand. Since it is not differentiable at 2, it is our critical number. Now, the third step is to find the values of the function at the boundary conditions. So we'll find the value of the function at -4. We'll find the value of this equation at +4, and also at the critical point, which is 2, right? So we'll find all these three values. So at -4, if I substitute -4 minus 2, I get a value which is -6. If I write +4, I got +4 as 2, and +6, obviously, always plus, right? And at 2, if I write, I get 2 minus 2, which is 0. Now if you compare these values, what do you get? You get absolute minimum here, right? And absolute maximum at this point. So these are the 3 points you need to check for. So let us say this is our -6 right here. So at -6 we are getting a value of +6. So that is our maximum. And at +6 we get a value of 2. So 2 will be, much lower than this. But anyway, since, okay, let's say this is 2, and okay, we'll go further, right? So let's say that was -6. Okay, so you understand what I'm trying to do. Let me resketch, since it does not really look like what we wanted to make, right? So we have an absolute function which is kind of like this. So at 0 it is 2, so that is 2, and so we'll have this as, and at +6, at +4 it is 2 also, so this is 2. So let me that looks better. Okay, so this is more or less correct, right? More towards closer to the real one. Okay, so that is how it is. This is our f of x. So in the function you can see that this is not to the scale, but anyway you get the idea. -4 and +4. Okay, so we are working on -4 and +4, and those are the values. +6, so this is the value 6. Okay, and at 4 you get a value of 2. So that is how the function looks like. So as I was saying, you should check for critical numbers. Here it is not differentiable at 2, and that happens to be your absolute minimum, right? Now let us write down our answer. So our answer is absolute maximum is at this point, which is -4, and the value is 6. And absolute minimum is at 2, and the value is 0. So that is how you should be answering these questions. So important thing is, check for continuity, check for critical numbers, find the value at upper and lower limits, and also the critical number. Compare the 3 values and write down your answer. That is how it should be done. Thank you.